Yesterday I watched this video by Roohif, and he found a couple of errors in this JTolan Media 1 video. This is another video that claims that we live on a flat earth, but in actuality it actually supports the globe model. What Roohif did was check the elevation. There's a total of 6 peaks here, and Roohif found the latitude and longitude of these peaks. And he checked them against JTolan's elevations. And peak A, B, C, and D up here, he confirmed that these were good elevations. But over here we have E and F. And Roohif found that this peak over here, 4,300 feet, this is actually 7,000 feet. And this 7,000 feet is actually 7,500. So I did an analysis. I used Google Earth and line of sights, and I confirmed exactly what Roohif found. And I'll go in a little bit more detail in about a minute here. So getting back to Roohif's video, the next thing he did is that he put in a ruler, and then he put in the correct elevations over here. And they all pretty much match up exactly with this ruler. And as Roohif says, sea level is way the fuck down here. So yes, this video again is absolute proof of the globe model. So I wanted to check Roohif's work and see if he did this correctly. So I went to Google Earth. JTolan is over here. There's a little peninsula near Santa Monica, and the peaks are over here. Now on Google Earth I was quickly able to find some of the peaks. Gabazon Peak and Fuller Peak, they both have a little peak symbol. They're easy to find, but the other ones were a little bit more difficult. What I did was found the topographic map, and you can see these topographic maps are nice because it's really easy to see ridge lines in the top of peaks. So I was quickly able to identify Fuller Peak. Here's 7,000 foot 5 level peak, and then Gabazon Peak is up in the upper left hand corner. It's not on this map, but if you look here, here is a ridge line in here, and this is a close-up of that. So here's that 7,500 foot peak, and I was also able to see there's another mountaintop right here. The elevation is not marked, but it's about 7,933. So I've added these two in. Now all of my elevations are what I found off of Google. They're a little bit different than JTolan's, but they're all very close. The next thing I did is I turned this 90 degrees so the line of sight was in the same direction as viewed by JTolan. This is from JTolan's video, and he has the top of these peaks all marked out. So the next thing I did is I put vertical lines from each peak, and then I identified them by the elevation that JTolan used. Next I made a cutout of this, and I laid the cutout over Google Earth. So here's a close-up of that. So I aligned Gabazon Peak with this, and San Jacinto Peak with this. Now the 7,500 is a pretty close alignment, but these two right here are quite a ways off. Next I went back, I changed this elevation from 4,300 feet to 7,005 feet. Change this to 7,500 feet, and then I added in this peak, because if you look on the video you can clearly see a peak right here. Now when I did an overlay, the matchup was literally perfect. Here's a close-up of it. So I aligned this end, and you can see that all of these peaks in the middle are lining up. So Roohif was absolutely correct, and JTolan had made a mistake. We do not see Gabazon Peak at all. Next, I did the same thing that Roohif did. I put a ruler in. Here's all the elevations. I aligned the 7,000 and the 10,800 foot levels. And these are not all a perfect match, but they're definitely very, very close. And as Roohif says, sea level is way the fuck down here where that mountain is. So this is definitely supporting the globe model. The next thing I wanted to do was check to see how close we are on the curvature calculation. So here we have the hidden figure for curvature, and this is the hidden figure with standard refraction. So doing the calculations, for the curvature visible, we should have 3,027 feet. For refraction visible, 4,285 feet. And one thing I wanted to check is, where is the horizon? It is actually about 15 miles away, so we do have a water horizon. The shoreline's almost another 5 miles away, about 19 point something away. So using the same scale, what we have is 5,300 feet of hidden. Here's the horizon, 5,300 feet. And there's actually 5,504 feet visible. Now, of course, this is not a perfect match with either the globe or the standard refraction curvature calculations, but this is the standard flat Earth mistake. They think that if they debunk the globe, then they have proved the flat Earth. And I think what we actually have here is a case of looming, definitely not compression at all. This is comparing the air rate for all three models, and yes, for both the globe and refraction, there's more visible than should be. 2,477 for the globe, 1,219 for the refraction. But this is where the flat Earth community makes a mistake, because they jump to the conclusion, look, I've debunked the globe, I've proven the flat Earth. No, what you need to do is also show that this observation fits the flat Earth. And in this case, the flat Earth is dead last. 5,300 is missing. And that's twice the amount of the globe. If the Earth was flat, the top of the peak should have been way up here, another 5,300 feet higher. Now I can already hear the crying, because people are going to say, well, that just looks like too much. Well, that's an assumption. So let's take a look at this of what actually was seen. How big is this in angular size or perspective? Perspective or angular size is just how big does an object appear in the distance. And it's based on the actual size and the actual distance of that object. In this case, the mountain should be 5,300 feet higher. So I've changed it to miles, so it's in the same units as the distance. This is the formula that I use down here. There are angular size calculators on the internet, and you'll get the exact same answer, 0.47 degrees. Next, I changed 5,300 feet to 0.47 degrees and changed my ruler accordingly. So from where JTolan was to the naked eye, that mountain was only 0.36 degrees in angular size. Not that big at all. Here's the sun for comparison, 0.53 degrees. And another way of looking at this is the tip of your little finger at arm's length is about 1 degree in angular size. You can actually block out the sun or the moon with that tip of your finger. And I recommend the moon so you don't blind yourself. So you can see that 0.47 degrees is not that big of a change at all. In conclusion, I want to give credit to Roohif for being the first one to find the errors in this video, and to also thank JTolan for making a video that debunks the flat Earth.